Hello everyone. So let us continue with the next type of problems in arches. So this is the second type of problem wherein you have a point load as well as a UDL. Okay. So let's check out the question first. A three-hinged parabolic arch of span 36 meter. So span is 36 meter and this is span 36 meter and rise 8 meter carries a UDL of 10 kilonewton per meter over left half span. So left half span, it is understood that it is exactly from the center, the C, it is to the left. So left half span is a UDL of 10 kilonewton meter. And then in addition, it carries a 2 point loads, 100 kilonewton and 150 kilonewton, acts at a distance 8 meter and 24 meter from the left support. Okay, so from left support, that is A, from here it is there is a UDL of there's a point load of 100 kilonewton at 8 meter and 150 kilonewton at 24 meter from the left support. Then you have to determine support reaction, draw bending moment diagram, and find normal thrust and shear at a distance 6 meter from both support. So it is now from both support, that is from A and B, you have to find normal thrust N and normal shear, that is the radial shear Q. Okay, so in exam they'll give you only this question, so you have to draw this arch. Okay, only the question will be given. So with just draw the arch, draw the supports, A, B support, hinge support, then C is also a hinged support, and then go on marking all these dimensions. Okay, so let's start with the first question. So first is determine the support reaction. In case if all the parameters are not given, in exam they might just give you find the bending moment diagram and normal thrust and radial shear. So it is understood that to find this bending moment, you have to find out the support reactions. Okay, so let us start with the first thing. First, find the support reactions. Now again, to find the support reactions, we have to use the equilibrium equations, that is summation H is equal to 0, summation V is equal to 0, moment about A is equal to 0, and because there are four unknowns here, HA, VA, HB, VB, so we have to take the additional moment about point C. Okay, so four unknowns with the four equations you can find out. Okay, so first is the vertical reaction. First find the vertical reactions, that is first summation H is equal to 0, then mark these. Horizontal forces are only two, HA plus minus HB is equal to 0. So only two horizontal forces, so write it here. Then summation V is equal to 0. So VA plus VB, because they're acting upward, so mark it. And of course here A and B are the hinge support. So hinge support has two reactions, that's why we have marked it as HA and VA. Similarly at B again it's a hinge, HB and VB. Okay, so now vertical forces, VA is acting upward, VA, VB upward, so positive, then minus, okay, these three loads are acting downward, so minus 100, minus 150, then there is a UDL here. Now because it's a UDL, so it is acting exactly half of the distance on the left span. So it is now 10 into 18 meter. Half of 36 is 18. So 10 into 18, because it's a UDL, you have to multiply with the distance. So load into its perpendicular distance. So these are all the vertical forces. So solve this, you'll get VA plus VB. Next, find moment about point A. So moment about point A, take all the forces acting. So now check this out. So VB is going in anti-clockwise direction. So anti-clockwise direction, negative. So minus VB into 36, VB into 36 plus 150 into this distance, 24, 150 into 24. Then again, this is going clockwise. So plus 100 into 8. Now this is a UDL. So because it's a UDL, so it is 10 into 18 into 18 by 2. Because it's a moment, load, this complete load, into perpendicular distance into distance by 2. That's how it is. 10 into 18 into 18 by 2 is equal to 0. So solve this, you'll get VB. So once you get this VB, put it back in the equation here, and then you'll get VA. So VA and VB we got to know. The next thing is find out the fourth quantity. Take the fourth equation, that is moment about C is equal to 0. So moment about C is equal to 0. Find out. So then again you can see to the left or to the right. The choice is yours. So I'll consider CB, because in CB there is only one load, external load acting. Okay. So if you see to the left or to the right, both the side you can check. Either ways you'll get the same answer. Okay. So now moment about C. So moment about C. So I'll see to the right side now. So to the right side, okay, VB. Okay. So it is VB into its perpendicular distance. Okay, so VB is going, we have already found out VB, so we have just put the value here. Okay, VB into perpendicular distance. Okay, then 150. Again, the sign conventions. Now it is because to the C, right side. So right side anti-clockwise is positive, clockwise is negative. So that's why VB, this is going anti-clockwise, so it is positive 167, and this is going clockwise, so it is 150 into 6, this distance. So 24 minus 18 is 6 meter. So it is 6. Then there's one more quantity here, HB. HB is going, so this is also going clockwise. So it is minus HB into perpendicular distance, 8. So once you solve this, you'll get HB. So once you find HB, put it back in the equation, you'll find HA. So all the 4 support reactions you have found out. Next, you have to find the resultant reaction. Now to calculate the resultant reaction, so if you want to find RA, it is nothing but it is the sum of HA plus VA. Then RB, it is again HB plus VB. Put it in this formula and find out. Then we'll get theta A, theta B. Again, theta A, tan inverse of VA by HA. Theta B is tan inverse of VB by HB. So you'll get theta and theta B. Okay. So we found out the resultant reactions. We found supported reaction and resultant reaction. Okay. Next thing is find the bending moment. Okay. So if you want to find bending moment, we know that bending moment at A, bending moment at C, and bending moment at B is 0, because these are the support reactions. So bending moment at the support reaction, that is at the hinges, hinge support, would be 0. That's what we have written here. Bending moment A, B, and C is equal to 0 because they're hinge support. Okay. Now that we know that it is a parabolic arch, 3-hinged parabolic arch. So we have the equation. We have the equation of a parabola. So that is y is equal to 4h lx minus x square divided by l square, wherein 4 h is nothing but the rise. So rise here is 8 meter. Next. Okay, 8 meter. Next. L is complete length, 36 into x. Keep x as it is because it is the distance where we have to find out the bending moment. So again, put this x square divided by 36 square. So put it in the equation and write it like this. So it is y is equal to 0.88x minus 0.025 x square. So it is a form of x and x square. So keep it as it is. Now this x determines, it is like the meaning of this equation is y is the vertical distance, x is the horizontal distance. It's like this. X is horizontal distance from 0 to 36. Y is the vertical distance from 0 to 8. So at any distance of x, you can find y. See, any distance of x made like this from B. If you want to find any distance x, you can find out the value of corresponding y value. Okay. So now we'll find the bending moment. Okay, now because this is a point force, we'll find bending moment at 100 kilonewton and 150 kilonewton. So we know that bending moment at 100 kilonewton is acting at a distance 8 meter. Okay, so now first we'll find out. See, x is 8. 100 kilonewton is acting at 8 meter. So we know x. for this x, we'll calculate y, that is perpendicular distance, like this, vertical distance. Okay, so we'll put it back in the equation. And bending moment at 100 kilonewton, that is at x is equal to 8 meter. So put it back in this equation and solve. So y is 5.44. Okay, now what you'll do, we know x, we know y. So at that section, okay, at that section, find out the bending moment. Okay, so at, see here, now at 8 meter, this is 100 kilonewton acting. So check to the left side. So left side, there are three forces acting: HA, VA, and this 10 kilonewton per meter. That is a UDL. We're cutting the section exactly at 8 meter. So because it is cutting this 100 kilonewton load, so we are not considering that. Okay. So now let us start this. So it's like this. VA, again, left side clockwise positive, anti-clockwise negative. Okay. So VA is acting clockwise. So VA into 8 meter. VA into 8 meter. Then HA is going anti-clockwise. So HA into, now height would be, we have already calculated y height. So y height is 5.44. And then this is a UDL. So it is 10 into 8 into 8 by 2. So check this section only at this point, left side. So similarly, we have written here, see, VA into 8 clockwise minus HA into y 5.44, and this is also going anti-clockwise. So minus 10 into 8 into 8 by 2 is equal to 0. So we got to know bending moment at 100 kilonewton. Next, similarly calculate bending moment at 150 kilonewton. Okay. Similarly, we'll calculate bending moment at 150 kilonewton. That is at this portion, 150 kilonewton. Okay. So now bending moment at 150 kilonewton is, again, first we know it is acting at a distance x is equal to, again, see here, when you're finding bending moment here, again you can see either to the left or to the right. Okay, so when I cut this section here, total is 36 and it is placed at distance 24. So 36 minus 24 is this distance, that is 12 meter. So now to the right side, if I check, there are only two loads, 1 and 2, HA, HB and VB. So now VB, so right side anti-clockwise is positive, so VB into 12. Okay, now before this, first we'll find out, this is acting at x is 12 meter. Let's check at what height is this placed. How much is this height? Okay, so we have the, again we have used the equation, that is x is 12 meter. So let us find out y. So put it back in the equation and be careful. X is 12 meter from the right support. So you have to mark it properly. So from right support it is 12 meter. So y is 6.96 meter. Okay, so we got to know. So VB into perpendicular distance 12. Then again minus, this is HB into its perpendicular distance, that is y, 6.96 is equal to 0. So calculate the bending moments. Now we can check out here. Bending moment at 100 kilonewton is more and bending moment at 150 kilonewton is less. Okay, now the reason why is bending moment at 100 kilonewton, there is a UDL acting here. That's why the bending moment here is more compared to this left half span. The bending is maximum because there's UDL acting compared to the right hand span. Okay. All right. Once you find out these bending moment, next thing is just draw the bending moment diagram. Here, bending moment A, B, and C. So first mark these points, draw this line arch. Okay. Then we know that bending moment at 8 meter is 347. So mark this 347.5 here. Next, similarly, bending moment at 12 meter. So at 12 meter it is 176, 177.06. So at C it is 0. So show here maximum 0. Again, compare. See here, this should be comparatively less, 177. And then back to the 0 line. So this is the bending moment diagram. All right. The next thing is calculate the normal thrust and radial shear Q at 6 meter from left support. Now again in this problem, they've asked to find both. Okay. Calculate the normal thrust and radial shear at 6 meter from the left support. Okay. From the left support, from this support, calculate the normal shear N and Q. Okay. Now here, again as usual, what you're supposed to do is mark first from this is the left support, mark the reactions here. So this is VA, VB, then this is like the arch. Okay, you are cutting the small portion. So this is the arch. Okay, then this is X distance, DX, and this is DY. Horizontal distance, DX, and vertical distance is DY. Okay, all right. Now this is the curved portion, DS. Okay, now what we're supposed to find out is first these two we have marked because we have already found out this. Now, how to mark this is important. See here, if this has to be in equilibrium, horizontal forces should be equal to horizontal right side forces should be equal to left side forces, upward forces should be equal to downward forces. Okay, if the system has to be in equilibrium, the arch has to be in equilibrium. Okay, so now these two parameters we know. Now that, see here, this force is acting to the right side. Okay, horizontal force. To stop this horizontal force, there is another force. Okay, it should be equal and opposite. So what I'll do, this is 263.74. The same thing, equal and opposite should be acting to the left side, which is 263.74. Same thing. Okay, now but there is a variation in the vertical force. Now this is 262.78, which is vertical, upward. Now, in this portion, now they have asked to find out at a distance 6 meter. You can see here at 6 meter. So if you have to find at a distance 6 meter, that is left side, there is also a UDL. 100 kilonewton is placed at 8 meter. But before that only you have to find out, that is at a distance 6 meter. So if you see to the left side, there is only one load, external load, that is the UDL load which is acting. So what I'll do is you have to consider this. That is 10 into 6. Okay, why 6? Because we are supposed to find at a distance 6 meter. UDL is acting throughout 18 meter. But our intention is to find only at 6 meter because it is asked in the question. Find this only at 6 meter. So it is 10 into 6. Let's here, 10 into 6. It is acting downward. So downward forces are taken negative. So 262 is written here. Same thing. Equal, opposite. 267, 262.78. But you have to deduct the UDL load because again the UDL also is trying to push the beam downward. So minus 10 into 6. If there are absolutely no loads between these 2 points, then you have to do equal and opposite. HA would be equal to this portion, VA is equal to this portion. Because there is a UDL, external load acting, that's why you have to deduct this portion. That is 10 into 6 should be deducted. So it is 262.78 downward minus the external load, that is 10 into 6. Okay, after this, you have to find out, as usual, once you mark all the forces, solve and keep it here. Now, this is the load we have to actually take. And this is the vertical force you have to consider. So next is tan theta. So tan theta is opposite by adjacent, that is dy by dx. Okay, tan theta is dy by dx. And then we've already calculated this y. So d by dx, write it as it is. Then y is, you have to write down the value. This is y. So put this value of y here and differentiate. Okay, so it is 0.88 times x. So because this is x, we are differentiating with respect to x, and this becomes 2 into 0.025 into x. So this is now tan theta. Now they have asked to find out at a distance 6 meter. Because it is 6 meter, means it is like the x distance. So put x is equal to 6 meter, and then put it back in the equation, and then you find tan theta. So tan theta is nothing but this angle. Now we'll get the angle. So this angle is 30.11. Okay, now when we get this angle, next we have the equation, that is normal, uh, n, normal thrust. N is v sine theta, h cos theta. Q is same. V and h should be same. Sine theta becomes cos theta becomes sine theta, and there is a change in the sign. This is same throughout. So substitute the value of V. Now see here, V is nothing but this portion. You have to deduct a portion because that is the actual vertical force which is acting now after deducting the UDL portion. So this is V now. V into its sine theta and cos theta, you can solve and keep it here. Substitute the value, and H is nothing but the horizontal force. Keep it here. Then you'll get normal reaction, normal thrust. That's normal reaction, of course. And then radial shear Q. Again, use this equation. Again, put the same value of V and solve this. So you'll get normal thrust and radial shear. Okay, that's it for today. Thank you.